Okay, we've got 9 people now, so that's good. Welcome everybody. So I'll just do a quick sound check before I start. Everyone hear me okay?
Yeah, all good.
All good, thank you. Thank you, Wayne. Yep, okay, so Cooper's there. Thanks, Cooper. So we might just do a quick recap on arrays. So this week's all on arrays. Okay, and so when you declare an array, you use square brackets. So if you see square brackets anywhere in Java, that's an array. So to declare an array of integers called arr, or whatever you want to call it, ints, or ints array, whatever you want to call it. You go int square brackets, followed by the name that you want to give the array, equals new int, and then inside square brackets, you can put a size, or it would normally be a lot better if you used a constant. So if you had final int max size equals 20, and then said max size, okay. That would be a better way to write a code. So you're using constants when you can, and put that right at the top of your class. If you want to declare an array of strings, it's the same. Oh, so this gives an array of ints, and they start at location 0. So int 0, you could say equals 3, int square brackets 1 is equal to 5 or whatever, and ints array square brackets 19 is equal to 99, 9, or whatever you want to put there. Okay, but the locations are from 0 to 19. So all arrays start at 0 in Java. Okay, so 0 to 19. And so here we've got an array of strings. And each element of the array here in this array is an integer. So when you declare the array, Java automatically initializes all integers to 0. So by default, all the data in the array is 0 to start off with, because it's an array of ints. Okay, so it's an array of 20 ints, and when Java creates an integer, it automatically initializes them to 0. So in most languages, you need to worry about initializing your array, set it to 0, whatever you want to do, and then work with it. But in Java, you can assume that it's been initialized, which is still pretty scary for someone who's done a lot of other languages and seen the issues. It's still a pretty scary thing to let Java take care of. But anyway, it does do it. Here I've created an array of strings called names, and there's 30 strings in this array. And again, I should be using a constant. Just get the habit of using constants when you can. And so there's 30 names, and the locations are 0 to 29. Okay, so there's 30 strings, 0 to 29, and by default, strings in Java are initialized to null. So every string in the array by default is initialized to null. Okay, got a question there from Jared. Just a sec, I'll just hop onto this question. When you say square brackets anywhere, that means an array in Java. Does it also include public static void main string args? Yes, it does. So what this actually means is, when you've got public static void main string square brackets args, an array of data is actually passed to Java when you run your program. Okay, and you can actually go args.length, see how much data is passed to your program. And you could loop through for int k. Oh, we're jumping ahead a bit here, but int k equals 0. K is less than args.length plus. And you could print out all the data that's passed to your program if you want. System.out.println square brackets k. And you can see what's passed to your program. So when you run your program on a command line, you use the TextPad does it for us, so we don't often do this, but you say Java followed by your class name, my class, and then you can also pass data to your program, like 1, 2, 3, and hello world, 4.567, and so on. Okay, so all of this data here is passed to your program when you run it. So all of this data here is passed to your program inside that array of args. So everything's passed as a string, and that args length would be 3, and args0 would be 1, 2, 3, args1 would be hello world, and args2 would be 4.567. Okay, so you can give that a try for yourself if you like. You can use that args parameter to get the data that's passed to your program. So if you're calling your JavaScript from inside shell scripts or batch files, you can pass parameters to them, and they can act on those parameters. Instead of getting user input directly, they could act on the parameters. Okay, so good question, very good question there. So the thing to remember with arrays is you've got an array of size n. You've got 0 to n minus 1 storage locations or index locations, index or storage. They're also called elements. So the elements of the array, the storage locations in the array, or the values of the storage locations in the array. Okay, so array of size n, you've got index locations 0 to n minus 1. So keep that in mind when you work with arrays. It's very easy when you're starting off to forget and assume an array of size 20. There'll be an error, index out of bounds, and your program would crash. Okay, so if you try and access 20 or anything else, your program would crash, which is great because Java protects us. If we're in C++ or C, you can actually go past the individual array and cause all sorts of havoc. But thankfully, Java's got that protection built in. Okay, you can also hard code data in arrays. If you know what the data is, you can set up an array. So int days per month. So that's our array. And I've got 31 in January, 28 in February, 31 in March. And if I want to keep going, I can keep going. So this automatically creates the array. You've got to use curly brackets, and you've got to use your semicolon, and you've got to have your data values separated by a comma. Okay, so this will give you an array of size 3, and the locations will be 0 to 2. And of course, you can do that with anything if you like. You can have an array of string called states, or whatever you want to call it. Open your curly brackets, type in the values separated by commas, okay, and so on, and keep going for as long as you like. Okay, and if it was just those 3, then again we'd have an array of size 3, and the index locations are 0 to 2. Okay, so that's quite a handy little shortcut for creating an array. If you know what the data is beforehand, when you're writing your code, you can put it in an array if you want to, or else you can create the array at runtime and put data in there using user input or reading it from file. Later on, when we read from files, you can do that, and all sorts of ways. And of course, the beauty of an array is you can loop through an array. For example, up here, states.length states, and you can just use a simple for loop to go through all the data in your array. Okay, so pretty cool. Or if you want to get user input into your array, state square brackets k is equal to keyboard.next line. So assume we've got a keyboard scanner object set up, and I can just say state k is equal to keyboard.next line. And I can type it, the user could type in a state, hit the enter key, type in another state, hit the enter key, for as many states as we've got storage locations for. Okay, so these aren't constants. This is just creating an array of strings, and we can change it anytime we like by saying state k is equal to something else, where k is an integer that's in the range 0 to 2. Okay, so don't forget your property. that it's array name.length. You can use it anytime to get the number of elements in the array. You certainly don't want to be doing things like hard coding 20 all the way through, or 3. If you find yourself hard coding the array size, stop and go back to using the array length. Or if you've got a constant set up, you could use the constant. That's fine as well if you had that constant set up. Okay, but either of those is fine. But don't go putting 3 or 20 or anything everywhere, because when your array size changes, you've got to change the size in multiple locations. Another thing I wanted you to keep in mind is, or want you to keep in mind is, when you pass an array to a method, you're passing the array reference, because arrays of reference data like strings and dates and employees. So the method has full access to the array and can change or edit, or if it wants to, it can corrupt the data as well. So just keep that in mind. There are various strategies to stop that, but they're outside the scope of this course. Okay. For now, if ever you want to pass something to, so if you pass an employee, in fact, let's have a look at this example. This code's included in the lecture for this week, and it's also in my GitHub. And I've got a method where we're passing an integer in, where we're passing an array in, we're passing an employee in, and so on, and passing a string, and a local date, and then I'm calling the method. So I'm getting the value beforehand, displaying it to the screen, calling the method, and then displaying the value back in the main program to see if it's changed. Okay, and if you pass an array to the method, and the array makes any change, and the method makes any changes to that array, it's reflected back in the calling program. So this will show different data. Okay, same with employees. So I pass an employee to a method. It's a reference to a memory location, so the method can make changes to the data. Okay, strings are a little bit different because they're immutable. And I recommend you watch the lecture video to see what immutable means. It means they can't be changed, basically. Or if you do change them, a new memory location is set up. Okay, so if I pass an employee through to a method, it can be changed. Afterwards, it can be changed to whatever I've changed it to in the method. But if I pass a string to a method, I'll set name equal to string, name equal to Mike, pass name through to the method. So string and Mike now refer to the same location in memory, but when I say string equals iField changed, Java says, okay, string, I'm creating a new string for this field, and it's a new location in memory. So str points to a new location in memory, but Mike still points to the original. So here I'm changing a local variable string without changing the original name. Okay, so this is creating a brand new string. Strings are immutable. They cannot be changed. If you do change, that means Java creates a new memory location. The original is still there, unchanged, even if nothing refers to it for a while. Okay, so after this, it'll be Mike before and Mike after, no matter what the strings change to. Okay, so a little bit different to employees. Strings are a special type of data called immutable data, cannot be changed. If you do change them, a new string field is set up and created with a new data, new memory location. Okay, so have a look through that example. Anyway, I'll go through that in detail in a lecture. So that's there for you as well. But just remember, if you pass an array to a method, you're passing something that method could change if it wanted to. At the top of there, I talk about strategies to employ. Yeah, so for now, if you don't want your data changing your employee or whatever, the safest thing to do is create a copy of it and pass a copy. And here's an example here. Employee 1 equals new employee, and I want to pass that to a method. So what I'm doing is going to create a copy of that employee, E1 copy, new employee, and get the name of the first one, and get the student ID of the first one, and whatever else. If there's any more data, I'd put that in there as well, and then pass the copy. Okay, so I'm not passing the original. So this original here is safe. If the method changes the copy, it doesn't matter. The original is still safe. Okay. And if we had a bit more time in this course, we could talk about copy constructors and other things as well, but they're outside the scope of this course at this stage. Got some other notes here, things you can think about as well if you want to. You know, what does final really mean? And well, we can talk about that quickly now. So if I had final employee E2 equals new employee, so what is E2? And what does final really mean? Does anybody want to have a guess what final really means? Okay, so when something's final, if it was final int, okay, so max is a constant, and if I try and say max is equal to 6 down here, that would be an error. So it's a constant. So when I say final E2 is equal to new employee, that means it's a memory location that refers to an employee, and that memory location where the data lives is a constant. So if I try and create a new employee in that location at a new memory location, that will be an error. That would be an error. Okay, so you can't change the memory location of where the data lives, of where the employee data lives, but can you do this? And the answer is yes. Okay, so I'm not changing where the memory is, where the data is for employee 2. I'm just changing the values that memory's got. Okay, so E2 is a location in memory where there's an employee. I'm just changing the name and the student ID of that employee. Okay, well, employee ID should be not student ID, but you get the idea. Set ID maybe. Okay, so this is quite okay. This is allowed. That's not allowed because we're changing the memory location or the value of E2. Here we're not changing the value of E2 at all. We're just changing the data referenced by E2. So that's perfectly okay. So you might think that making something final in a method header might protect it, and it doesn't. Okay, it doesn't protect it at all. There's a really good book if you're interested in this. If you want to read deeper, although I recommend you don't read deeper at this stage, I recommend you leave it till perhaps after the follow-on course. It's pretty complex stuff. Okay, and there's Joshua Block's written this fantastic book called Effective Java, and one of the advanced topics he talks about is this overriding clone method judiciously. And it's a deep dive into what happens inside Java. Okay, but that's something I'd recommend for after you finish follow-on Java course. So don't do it now. You'll come away with a headache if you read it now. It's pretty tough going. Okay, there's a lot to digest. But that's there for the future if you want it. Okay. Any questions so far on arrays? Any? Do you want to see command line parameters in action? We can do a quick example if you want. Do you want to do a quick example, or do you want to have a go on your own? Or should we just move on with the tute questions? Okay, I guess we move on with the tute questions. Nothing in the chat window. Got 10 people. So one thing I didn't talk about up here that we talked about in the lecture was you can use an enhanced for loop. So for each string called S in our states array, you can then output that string to the screen. Okay, so states is an array of strings. So for each string in our states array, and I'm going to call each string S, we're looping through all strings and just printing it to the screen. If we want to do our days per month array, we do the same sort of thing. Days per month. So for each integer val or k or whatever you want to call it, output val. So we're outputting all the values in the days per month array. Okay, so that's called the compact for loop, or the enhanced for loop, or the for each loop. It's all the same, just a compact version of the for loop. So what benefits does the enhanced for loop provide for array processing? What are the limitations? So benefits. Anybody got some benefits? Let's have a look at them side by side.
So the code that you use inside the loop is a bit simpler because you don't have to do the array index and all that.
Exactly right. Yes, that's exactly right. So it's simpler code and less code. And also you're guaranteed to loop through the whole array. If you use a counter-controlled loop, maybe you set up the counters wrong. Maybe you start at 3 or something by mistake, or 1 by mistake, or So you can sort of, if you're not careful, you can mess it up with looping through a counter-controlled loop. But with a for each loop, you're guaranteed to loop through the entire array. Unless you break out, of course, of the loop using the break command. And what's the limitations of the enhanced for loop?
So it doesn't have the versatility that you could have with a for loop, like you could start at a different point in the array or finish earlier, that sort of thing.
Exactly right. Exactly right. So you cannot start halfway through the array. Exactly right, Wayne. And Jared's got it too. Jared's been writing smaller code. That's right. And so you cannot start partway through. You can still bail out early if you use the break command. So you could say, like, if the state name is Queensland break, and that would break you out of the loop. So you can still break out. And the other thing you can't do is you can't say, like here, you could say state plus k plus 1. You've got access to the counter. So you could say state 1 is Queensland, state 2 is New South Wales or something. So you can display the value of k. But down here you can't do that unless you introduce extra fields. For example, you introduce a counter, 0, and you go count plus plus, and then you go for state. Okay, so to get it to do the same thing as this loop, you've then got to introduce another 1 and 2 lines of code, which you might as well use a counter-controlled loop. Okay, so you don't get access to the index. You don't get automatic access to a loop index. If you need a loop index, you need to create your own, for example. Create it there and add one to it when you need to. That's good. That's all good. What's an off by 1 error? Off by 1 error. We sort of hinted about it up here.
So it's what happens when you don't logically account for the fact that the array starts at 0.
Exactly right. Yep. So it's, if you're going to array size 20, you try and access the data at location 20 or 21 or 22, but usually it's just the end of the array. You go one too far. Yeah, so it's just that error there.
Also, when you're trying to point to the first element of the array, and you put 1.
Could be 2, exactly right. Yep, so down here, if you start at 1, that could be one off by 1 error, or if you do equals, then you're looping through up to and including the length of the array, which could be 20, means you've exceeded your array size down here when you go states K. So that could be an off by 1 error, and that could be an off by 1 error too. You don't start at 0. So that code there has 2 off by 1 errors. And that one there will cause your program to crash when you get to 20 or whatever the number of states is. And you try and access that location of memory, which isn't part of the array, your program will crash. Why are command line arguments passed to the main method as strings? What problem would arise if command line arguments were passed using an array of doubles? Okay, so we're getting a little bit deep here. So it's asking, let's go back to our command line. Passed using an array of doubles. So we have to do something like this. That's passing an array of doubles to your main program. What would Java read that in as? Okay, so everything comes in as a string. Everything comes in as a string. But how many strings would that be? And what values would they have? Okay, 0, 1, 2. So it would be passed in as 3 strings, that's right. And the first string would be that. Okay, so if you don't put quotes around it, spaces are what delimits the parameters. So that would be one parameter. The next parameter will be 33.45, including the comma. So that would be args 0. args1 would be 33.45, and args2 would be 66.78, and the closing brace. And if for some reason you had a semicolon there as well, that would be included. So it's everything up until the next space. We can verify this pretty quickly if you want. Might as well. Hopefully you do this as well, but I'll just show you quickly. But it's good little exercise to do this. Compile it, and then I've got to get to the command line. Okay. I could create a little batch file and run it, but I'll get into the command line. Okay, so there's my compiled code. My class.class. So we could run that. Change the prompt. $G. Get rid of all the paths from the prompt. Sorry, make it a bit shorter. Let's run that. Java, my class. Okay, no parameters passed. Let's now pass this array. And you'll see there's what we, curly bracket, 1, 2, 3, 4, 5, 1.5, comma, that's all the first string. 3 to 3.45, comma is the second string. And 66.78 curly bracket is the third string. So that proves that the data's passed in as a string. And also anything included, commas, curly brackets, that's all read as part of the string as well. So it's all space delimited. If we wanted to read it in as one string, we could put quotes around the whole lot. And that would read it in as one string. Okay. So now you got it in as a string. You could still process it. You could still, there's some string routines we could talk about, but where you can find whether things got curly brackets in and strip that data out and ignore the comma and or replace, just actually replace it with the easiest. And then once you got the commas and the curly brackets taken out, you could then do an integer.parseInt or double.parseDouble to convert them into doubles. Let's do that, just for fun. I'll do it over here in this one. Args equals args.replace. Replace the commas, opening curly brackets, replace the closing curly brackets, replace the commas. That's all we had to do. And then there you can see we've got something that looks more like numbers. So I'll put off the curly brackets, I'll put off the commas. Okay. And then we could do a double.parseDouble. Print to the screen to make sure we're doing the right thing. D1, sorry, D1. There we go. So we got the doubles 123.5, 33.45. So even if your data comes in as strings, you can very quickly get rid of any junk that's around it and convert it to what you need. So it's not hard. Okay, so I haven't done replace yet, but that's a great little command to replace characters in a string. And there's other functions as well that we haven't talked about yet. So there's substring, index of, to find a string inside another string, substring to get you just part of the string, so you can pull characters out of the middle of the string or whatever you like. To uppercase, to lowercase, and other ones as well. So there's lots of useful functions there inside the string class. Question 2, declare and create an integer array called numbers. Any questions on that? Any questions on what we've done so far? I realise we went off on a slight tangent now looking at the command line parameters, but it was part of the question. So if you pass an array of doubles, they're going to be read in as strings. And if you've got curly brackets and commas, they're going to be read in as, that's going to be read in as well. So they're not going to be doubles. You have to process them. For example, pulling out the junk and doing a conversion. Okay. But any questions on anything so far? We've still got 10 people, which is good. No questions. Nothing in the chat window. Okay. Create an array of integers called numbers with the following in a class called myArray. Okay, let's do that. They called it myArray. Let's call it myArray. Public. Save as. I should have made sure the Java was togged. There we go. That's the curly bracket. Hang on, wrong bracket. There we go. So the question says, declare an array of integers called numbers with the following numbers in the class called myArray. So it's so where should we create that array? Creating it in there for now. It doesn't say where to create it. It doesn't say whether to create it here or up here. So I'm just creating it in the main method for now. And we'll read on and see if we're on the right track. Write a for loop which traverses the array and outputs the numbers on a line separated by spaces. Then write an enhanced for loop. Okay, so we've got part A done. Who wants to have a go at the normal counter control loop? We'll do it both ways, counter control loop and also the enhanced for loop. If someone wants to write the code for that. And if someone wants to write the code to add up the values in the array, so we can get the total of the array values and also find the maximum and the minimum, we'll do that as well. Okay, so anyone wants to write any of that code into the chat window, please do. And then there's another, the part E's, write a method which will accept the array as a parameter and an integer as a key, as a parameter. So the array and an integer. And the method will search the array for the key value and return the index of the found value if it's found, or -1 if the value is not found. Okay, so I'll show you what that method might look like. So we're passing in an array and also the value to search for. So we're going to have for loop and looping through the whole array till we find a match. And if we don't find a match, we're going to return -1. And if we do find a match, we're going to return the index of the found value. Okay. So that's part of the code you need. Okay, good. Wayne, excellent. Thanks, Wayne. With the value, the code here to find a min and max. Beautiful. Paste it straight in. Okay, so let's just check Wayne's code. So we've initialized max to the first item in the array, which is perfect. Okay, and initialize the min to the first number in the array as well. That's great. You've got to be very careful when you initialize the max and min. Don't make up values, because if you make up the value, the max is 100. Okay. And all the data in the array is smaller than 100, this will still say the max is 100. Okay. And if you assume all the data in the array is positive and you make the minimum 0, the value 0, and you've got negative data in your array or data that doesn't go down to 0, so you've got numbers that are all greater than 0, you also have a minimum return of zero. So you got to be very careful there. The only safe value to use is the first item in the array, which is what Wayne's done. So that's perfect. If value in the array is greater than the max, we've got a new max. So max equals val. If value is less than a min, we've got a new min. So min equals val. That's perfect. There is one super slight issue here, and it's only super minor, and that is we're setting the max to the first item in the array, and then we're checking the first item as well, because this goes through all items in the array. And I think that's such a minor issue that it's not even worth worrying about. There are some programs out there though that do get worried about that sort of thing.
So it's actually like that because in my program I had the code to create the sum, the total.
Yes, okay, yep.
In that loop as well.
Yeah. But I'm saying it's such a minor issue. Don't worry about it. And unless it's a huge array, or you're doing it many thousands of times a second, don't worry about it. Okay, it's such a trivial thing. But if we did want to avoid that, if we were working for a company where they were super concerned about getting the most efficiency as possible, you could say int k is equal to 1. K is less than numbers.length plus. So we're starting at the second item in the array, not the first. Okay, so if that did worry some people, you could skip the first item because you've already processed the first item here. Okay. But that's only for people who are super worried about squeezing the utmost efficiency out of your code. Okay, that's the min and max. That's great. Thanks, Wayne. Anybody else got any code for me for the outputting the data to a line separated by spaces, or using the enhanced for loop? Nobody else? We're 12 people in the class. 12 people. Okay, so Wayne's done that part to work at the maximum minimum. We'll still need to work out the total values in the array. Adds up the values in the array. And we still need to take a list method as well. But I'll give people some time. Yeah, for loop. Okay, well, let's go ahead and do it. I might comment this code out for now just so we can compile and run, do some testing. And of course, once you use the array, you've got to use numbers, square brackets k, and upper square brackets k, and upper square brackets k, and upper square brackets k. You don't no longer have val, of course, if you use the other way. Cool. Nothing's coming out yet, but we'll add some code down here to display the maximum and minimum. System.out.println max min. Okay, so max is 98, minimum's 12. 98 and 12 looks like it's pretty good. Yep. Okay, so excellent. Yep. So Wayne's provided us the code to work out the total as well. We wouldn't want to add it to this loop because I've skipped the first item. So we might go back and add a standard for loop as well, or enhanced for loop. And int total is equal to 0. Total plus equals val. Okay, so we've got the total now, and you don't have to technically do equals 0, because don't forget Java initializes everything to 0 by default if it's a number, a primitive data type number. But I just still like putting that in It doesn't feel right to me without putting that equals 0 in. It had it knocked into me through so many other programming languages where you've got to initialize everything, so I just can't help it. I've got to do it. And I think it's good practice too to initialize things, even though Java does do it for you. Let's display the total. And we'll do a compile and run. So the total is 526. Nobody else has got the other code. Okay, let's do a loop that outputs numbers 1 per line, separated by spaces. Let's write that code. Of course, you could combine these loops and do everything in one loop if you wanted to, but I'm just separating it out just so you can see the parts. So system.out.println, val plus separated by spaces. Make it print. Okay, so there's the numbers printed to the screen with the enhanced for loop, separated by spaces. What else? We do a standard for loop. So this is called a counter controlled for loop. And we start at 0. In the value, you've got to use the array now, number and index, number square brackets k to use the array and the index. And we're not skipping the first item anymore. So start at 0. Or k is less than number.length k plus plus, and output the value of that location plus a space. Okay, so we're both getting the same answer, counter controlled or the enhanced for loop, doing exactly the same thing. The max, the min, and the total. While we're on a subject, let's also do the averages. Int average equals, see if someone can fill that in, not Wayne. Wayne's done too much. And we'll have a double average as well. Average. DBL average. So see if someone can know what those calculations are, and we'll display those as well. Average I and average F for floating point or D for double, whatever you want to say. I'm just using a bit of shorthand to make everything line up nice. Int average and double average. So we've got 12 people in the class. Can anyone provide how to do the average? Surely. you've just done it in your assignments. So okay, well, we've got total. I'll help you with the first one, divided by numbers.length. And of course, that chops off the decimal places because we're dividing an integer by an integer. So the result is an integer, so we've got no decimal places. And what was the trick for getting the floating point average, the accurate average? Okay, so there's many ways to do it. The easiest way is just multiply by 1.0. 1.0 times, okay, so you're forcing this to be floating point numbers, which means that's promoted to be a floating point number as well. So it's doing floating point division, which gives you the decimal places as well. So the average 52 is the integer average and 52.6 is the accurate average. Let's write the search method. So how we want to call this is we want to call it like this. Example use search numbers for the value 12. Index is equal to search numbers for the value 12. So it should start here at 0, at the location 0, not 12, not 12, not 12, not 12, whoops, not 12, found it. And it should return the index of that value. So it's 0, 1, 2, 3, 4, 5 should be the value returned. Okay, so that should return 5. And also if we do this one, for the value 3, then it should return 3 is not in the array, so it should return a value of -1. In other words, value not found. Okay, so let's write the code. So we probably want to use we can use any sort of for loop, the enhanced for loop or the counter controlled. I'll use a counter controlled here. Let's create an integer called found index is equal to -1, set it to -1. And if something is equal to something, we want to do something here and also do something there. For example, exit the loop. And we want to return the value of found index. We're looping through the whole array. If we find a value we want to search for, which is that chap, if we find that in the array, then we want to set this index to the location and also exit the loop. Okay, so if we've got a loop of 3 million integers and we find it after the first 5, we want to exit the loop then, not search through all 3 million. Okay, we just want to find the first occurrence. If there's multiple occurrences of a bit of data, we don't care about that. We're just going to find the first occurrence. Okay, so can anyone tell me what I type here and here?
Am I allowed to answer?
I guess so, Wayne. There's nobody else really stepping up at the moment.
So it'll be if array.
Okay, Jared. Sorry, Jared's distracted. He's okay. Sorry, Jared. Go for it, Wayne. Yep.
So if array in brackets k equals search val.
Yep, perfect. And you've got to make sure you use a double equals there because you're doing equality. Don't use a single equals. And then what do we want to do here? Anybody else? So you want to say found index equals something. And then you want to exit the loop. Okay, so found index equals k. And what's 2 ways we know to exit the loop? Probably the easiest way is just to violate this. So k is equal to numbers.length. So make it so it violates that condition. you wouldn't want to set it to 100 because you don't know how big the array is. So you've got to use the array size. And anything bigger than numbers.length minus 1 is going to work. So numbers.length is fine. That'll exit the loop. And then return found index. So that should be it. Let's copy these two examples down to below, and we'll call those. I'll call that index 1 and index 2. Index 1. Search for 3. Return index 2. Okay. Control 1. So it's array.length. It's whatever array is called. Array.length. So that numbers is declared here inside our main. It doesn't exist here, so we can only use that array, whatever it's called. We can call it numbers as well if we wanted to, but I've called it array there. Control 1, control 2. So 12 was found at index 5, which is what we thought. And 3 wasn't found at all, so the function returned, or the method returned -1. Okay, which means that it's not found, which is good. Okay, so any questions on that one? So we've done it. We've more than answered the question because we also did the max and min while we're at it. And like I said, you could combine all of these loops into one if you wanted to, and have the maximum, the minimum, the total, the displaying the data all done in one loop if you wanted to. That would be quite okay. Okay, so Wayne's got some other test code. Cool, cool. Whoa. Nice. Let's do that. Let's put Wayne's code in. Very clever code here. Okay, so Wayne's choosing a random number, and math.random returns a value between 0 and 1, a floating point value. So I'm multiplying it by 10. So that bit of code there returns a value between 0 and 9.9999999. Okay. And then Wayne's getting the floor, which is the next whole number down. So it's going to give us a value between 0 and 9, 0.0 and 9.0. And then we're getting the integer value of that. So it's going to be between 0 and 9. Okay. And then we're searching the array for that value. Okay. Oh, sorry, this is just choosing an index. Sorry, it's choosing an index, and we're using the index to look up the array. Okay. And then searching for that value and displaying the result. Cool, cool. And you can see 42 is found at location 0, which is correct. There it is, location 0. And 27 was found at index 3. 0, 1, 2, 3, 27. So like I said earlier, whenever you deal with arrays, the first thing I do, especially if they're written on paper or in an exam question, or even in my own code, I do it. I put the index numbers on top. Okay, so it's not a bad thing to do. Whenever you see an array, put the index numbers on top of that, especially if you're in an exam when there's a lot of distractions and you're under pressure, put the index numbers on top straight away. Do it during, you can even do it during perusal time if you can. Okay. 98 is index 6. 98 is index 6. Correct. 72 is index 4. 72 is index 4. Perfect. Okay, so that's all working great. Well done, Wayne. We could modify this slightly by using the array length. So we've got 10 items in the array. So instead of hard coding 10, we could also use the array length, and that would make it even better, even more bulletproof, and also the array length here. And that just means we're not hard coding 10 in case the array size changes. But that's great. Perfect. Well done. Still getting the same results. Righto. Any questions on that one? So we've done a lot more than the question asked. We've done the max and the min. We've done the averages, the integer and the double point or floating point average. And we've also used Wayne's clever code here to do searches for every item in the array at random. Okay, so done a lot more than answer the question there. And we've written the code and tested it, so that's all good. So no questions, okay, let's go back. So I've got some review questions to do, and I've got the programming exercises. So the review questions are there in your textbook on page 430. You can start there if you want to. We've got an hour left, so I thought I'd do some programming questions where we use an array of objects. Let's get to the real meat of the matter. An array of objects, for example, an array of employees, an array of products, an array of customers, doesn't matter what they are, an array of students. But let's go ahead and do one of these examples that does that sort of thing. Okay, so and I think the salesperson might be a good one to start with. Create a class called salesperson with data fields, an integer for ID number and a double for sales amount. So just two fields, a salesperson ID and their sales. And include methods, a constructor that requires values for both fields. So it's a parameterized constructor. As well as get and set methods. Write an application called demo salesperson that calls the methods. So quite a lot going on here. So let's start with salesperson. Public salesperson. Two fields, private int ID. If you want to call it ID number, that's fine as well. ID number. And then annual sales, so private. And it's a double. Okay. And then it says to create a constructor and set and get methods. So let's go ahead and do those. So if someone wants to do this, the get methods, or a get method, someone wants to do a set method. If someone wants to do the default constructor or the parameterized constructor, you can do that as well. Okay, so if anyone wants to type ahead and do some of the methods, that'd be perfect, that'd be great. But this sort of thing should be hopefully becoming bread and butter to you now, that we create a class, we create the constructors, we create the mutators, we create the accessors. Usually we create a two-string method as well. And hopefully this is becoming second nature for you. We're just following like a recipe. We're following a pattern every class we create. One thing I like doing is putting a closing reference on that closing bracket, closing brace. Okay, let's start with the constructor then, salesperson. It says salesperson, okay, salesperson. Follow around brackets. That's the default constructor. Then it says to provide one that takes values to both data fields. So we've got an ID of number, double annual sales. So can anyone fill in the blanks there? Public something, get ID number, public something, get annual sales. If you don't want to provide the header, you can just fill in the body if you want to. Then the setters, set ID, set annual sales. It's bringing in an ID. It's bringing in an annual sales. So with all the method headers there now. Also do a toString as well. Should do a toString in all your classes. Okay, so if anyone wants to provide the implementation for any of those methods, please feel free. I like it, Wayne. Yeah, so Wayne's given me the default constructor, and he's remembered the lovely little shortcut of calling your parameterized constructor. That's perfect. Save yourself code. So Sanjin's there. Sanjin's usually joins in. Jared's distracted, but he usually joins in. Yeah. Okay, let's do the parameterized constructor. So ID number equals ID number, annual sales equals annual sales. And we need to tell Java that we mean the class instance fields here. So we need to put this in front, this dot. Okay. Get the ID number as returning an int, because ID number is an int. So that's going to return an int. And I'm going to return ID number. The accessor methods are usually very, very simple. Usually just one line of code, return something. That's all I do. Occasionally you might need to construct averages or call methods to get totals or something, but usually they're just very simple. Get annual sales is returning a double, so it's going to be public double, and it's going to say return annual sales by the semicolon. Okay, so we've done over half our class so far. We're just following the recipe that we've always done. Create a default constructor, create a parameterized constructor, the accessor methods, and now we're onto the mutator methods. And then we've got the toString, just a recipe we've done many times before. Set ID number is going to do the class field or class instance field ID number to the one that was passed in. So we'll just grab that code from up here. Annual sales is going to do the same for annual sales. And we're not doing any validation, we're not doing any checking, so there's nothing going on. So we're don't need to return whether it was true or false, whether it was succeeded or not. So we're just going to make it a void method, keeping it as simple as we can. Okay, if this is a real class for industry, we would be returning a Boolean here and returning whether it was true or false, whether the results were successful or not. But we're just keeping it very simple here. And that's it, we've done our class. Oh, toString. ID number plus annual sales. We probably want to format our data a bit nicer than that. And salesperson ID number. We might want to make this with 2 decimal places. So let's do that. String.format %.2f close quotes, comma, annual sales. And if you want to make it so all the annual sales values are the same width, you can make them all 10 characters. So there's 10 characters of numbers there, and we can put the comma separator in and a decimal point and 2 decimal places. So this 10 is 10 in total, and it includes the 2 decimal places, the full stop, and any commas that are needed. Anything else is just spaces. Any leading zeros are just spaces. Test compile. All good. So any questions on that? So this should really be bread and butter by now. So you should be able to knock up a class like this pretty quickly. Okay. The second part's creating a demo salesperson. Let's do that. Public. I might change the name of the class just slightly. I might make it salesperson demo, because I've got a lot of files in one directory and I want the salesperson and the salesperson demo to be listed together in the folder. So I'm going to change the name slightly. Salesperson demo, salesperson tester, salesperson runner. They're all okay. This is going to have our main method, public static void main, string, square brackets, args. So what the question says is, declares an array of 10 salesperson objects, set the ID to 999 and each sales value to 0, display the 10 salesperson objects, and save the files salesperson Java and demo salesperson. So let's just copy that over to our main method for now so we can keep an eye on that. So we want to declare 10 salesperson objects. It doesn't say what the array name is, so we'll just make up an array, and salesperson, squares brackets, sales people equals new salesperson. An array of 10 objects. I recommend you make the 10 a constant. Always make the size of the array constant if you can. Final static int max size equals 10, and use that to declare your array down here. Set each ID to 999 and each sales value to 0, and then display the salesperson objects. So we'll use two loops. Just for fun, we'll use two loops. I'll do a counter control loop to do the setting, and then I'll use an enhanced for loop to do the displaying, just for fun. Okay. Let's use a counter control loop for int k is equal to 0, k is less than. Now we can use a constant here. That's perfectly okay. Or we could use the length of the array, dot length, and both are perfectly okay. So you can use a constant or the as long as you're absolutely sure that constant is used to declare the array, then you can use the constant, or else you just use the length of the array. Array name dot length. Okay. So we want to create each salesperson. So this gives us an array of salespeople. So we've got 10 salespeople to create it, but it's like doing this. Okay, so it's like doing that. We haven't done that. We haven't created the salesperson yet. We've declared them, but we haven't created them yet. We haven't gone equals new salesperson. So this has given us an array of objects that look like this. And if I displayed P1 to the screen, what would I see? I'd see the null memory address. Okay, so this is an array of null memory addresses at the moment. They're all of type salespeople or salesperson, but they're all null. Okay, so we need to do the equals new salesperson. That's when the memory actually gets reserved for a salesperson object. And they've each got an ID and a sales. Okay, so that's what we're working towards down here in our loop. So for each element of the array or each location in the array, let's create a salesperson. So salesperson square brackets k equals new salesperson. And it says to pass through the values 999 for the ID and 0 for the sales. So we're just calling our parameterized constructor. Let's have a look at our parameterized constructor. So it takes an integer, which is an ID number, and a double, which is the annual sales. So we need to pass through an integer and then a double. An integer and then a double. So we're calling it the right way. We should be able to compile our code. Control 1, Control 2. Nothing's been displayed to the screen yet, but there's no errors, so that's something. Who wants to have a crack at doing the enhanced for loop to display the data to the screen? Anybody want to have a go at doing part of the enhanced for loop? Can anybody do the header and somebody else do the body of the method, the body of the loop? Still got 9 people. 9 people. I know Wayne can do it standing on his head, but I was just trying to get someone else to have a go. I'll have a sip of coffee. Okay, so no takers, nothing in the chat window. Let's have a look at an enhanced for loop. For, what are we looping through? What type of data? It's salesperson. So for each salesperson, I'm going to call them SP for salesperson. Inside our, yeah. Oh, Jared, yeah, nice one, Jared. Yeah, you're quite right. You're quite right. Yep. So Jared's got the answer there as well. Yep. So for each salesperson, we'll give them a name called SP in our salespeople array. So whatever the data type is to the array, that's what you use here. And give it a name. Any old name will do. That's valid. Colon, and then your array name. And then we can display that salesperson. System.out.println. What would happen if I just type SP? What would Java do if I just typed SP there? We talked about this in last week and also this week, I think, in the lecture. Okay, so Jared said null. If we hadn't initialized them, if we hadn't created them up here, you're quite right, Jared, it would have said null. Okay, but we've created our salespeople. I know you've only just got back, so that's quite okay. Okay, but Java says, right, you're trying to print the screen, the salesperson to the screen, so you need a string representation of the data. So let me have a look at your method or in your class and see if there's a toString method. And Java automatically looks for it and finds it and calls it. Okay, so we'll see a salesperson 999 with a sales of 0. Okay, so Java automatically calls the toString method if it's available. Unknown formatted conversion. I've got something wrong there. Control. There we go. Okay, so the salesperson 9999, and they're all zeros, the amounts. If we hadn't initialized the data, what we see on screen now? We'd see nulls. Okay. And if you have a look at our toString method, you'll see there's no way this can produce a null. Okay, so when you haven't created the object yet, Java isn't even calling your toString anymore. It says, you haven't even created it yet. I'm not even going to try and access it. So it's just going to return null. Okay, so that's what Jared said. He was quite right. Okay, but when we create the data, or create the array elements, and then loop through them, we're getting those values. So we could have a look at, we could use Wayne's clever code from before, and let's have a look at that. And let's generate some random numbers. Put some random data into our salespeople instead. Okay, so let's do that. So here we've created them that way. Let's comment that out. That returns a random value between 0 and 1, a floating point value. Let's multiply that by 1000. Okay, and that will give us a floating point number between 0 and 999.99999. Okay, let's convert that to an integer. Okay, so we're getting that random number between 0 and 999.99999 and converting it to an integer. Let's also do the same with their sales. But we don't need an integer for sales, so we can just take that off because our floating point number is quite okay for their sales. And let's assume the maximum sales is $55,000. Okay, so we've got 0 to 999 for the ID and also a random value for the sales. Okay. Now this could have dangers because we could by chance we could be allocating the same ID to 2 employees or 2 salespeople. That's okay. We'll deal with that for now. We'll live with that for now. It's just for fun. Okay. So let's run that and see what happens. And you'll see we're getting our IDs coming out and our amounts. And you'll see this is stepping in a bit, so we could make it so it formats up with 4 digits if we wanted to. So let's do that. So string.format. Remember your string.formats. It's so useful. String.format. We're formatting integer data here, so it's %d. Okay, so %d, and we want to tell Java how many digits to output or how much space to leave for the digits. And we could say 4 for 4 digits. Okay, control 1. That's all fine. Control 1, control 2. You'll see no matter what the ID is, it's still lining up nice and neatly over here. Let's get a comma separator working. So it's just a matter of figuring out, have a bit of a play, work out where to put it. So it didn't work there. That gave me an error. Let's try it here. Just have a play. If you can't remember what the answer is, just have a play. There's only so many combinations. Control 1, control 1, control 2, and that worked perfectly. So now we're getting our 1000 separator in as well. And you might be thinking, well, those numbers are getting pretty big. We've only got 1 more digit before we run out of space. Let's put a few more digits in. Let's make that a 12-digit space. And let's leave a few more, bit of a space between the next column of data. Okay, so a few spaces here and increase that to 12. Control 1, control 1, control 2. And see we've got everything spaced out nicely. Okay, so this question, where we're creating an array and then creating an array of it and calling methods, that's really bread and butter for our course. Okay, let's do some more things. So let's create them the old way, and instead of creating them with this math.random, let's use the accessor methods or the mutator methods to change the class data. So salesperson.set, and what's the method called? Set ID number to that same code. We're creating the original way with 9999 and 0, and let's allocate them a random ID and then allocate them a random sales as well. So set annual sales, salesperson K, and we want to grab that code from there. And of course, we want to do this in a loop. Okay, so we created them with 1 value, and then we're changing them so their IDs have changed and their annual sales have changed. Control 1, control 2. All working nicely. Now that we know how to do that, let's go through and increase all annual sales 15%. So you can write the code for that. And, or actually, let's increase it by $100 to start with. So whatever the annual sales are, add $100 on it. It's Christmas time. We're going to give everyone a bonus. So increase their annual sales, and also that means their bonus is going to be bigger. Okay, by $100 or $1,000, whatever you want to do. And let's get the total sales. Okay, so it's a really good thing to do when you answer a question, to then extend it. Think, what else can I add to make it? So I'm exploring further, and that's all we're doing here. So and this is displaying final results. We're going to do three things here. We're going to increase the sales by $100, everyone's sales, get the total sales for all salespeople, and get the average sales. And we want to display them as well. Display the total and the average. Okay, so if anyone could write any of that code, the calculating the extra sales or the totals or the average or displaying the values, please feel free to write it and paste it in the window, and I'll include it in here. And go back to this other code before. This is Wayne's code. That's heavily based on Wayne's code as well. Okay, I'll do the total. So double total sales is equal to 0.0. Again, remember, you don't have to do that. You don't have to say equals 0.0. Java does it automatically. But I just like doing it. It's just a habit of a lifetime. So let's grab that loop. We're going to be saying total sales plus equals salespeople dot something. So what do we put in there? What do we put there to get their sales? Hint, it's an accessor method. And over here, say dot something, and then salespeople. Actually, let's do it in 2 lines. Double sales is equal to so we're getting their current sales, we're adding 100 to it, and then we're changing their current sales or their annual sales, whatever it is. Annual. Okay, so there's some blanks to fill in there. So how do we get the sales for a salesperson? Let's have a look at our class. It's not the constructors, they're not going to help us. Get ID numbers not going to help us. Aha, there it is. Get annual sales. Okay, so annual sales is get annual sales. Add $100 to it. And then update that in the class. So how do we change the annual sales? We could create the salesperson again, but that'd be pretty messy. The accessors aren't going to help us. The set ID number is not going to help us. Aha, the set annual sales. That's the one we need. So set annual sales to whatever the new annual sales is. And of course, if you don't do that on 3 lines of code, you can do it all on 1 line of code. Let's do that. So you can do it all on 1 line of code if you want to. So get their annual sales, add $100 onto it, and set their annual sales to that new value. Down here, we're getting the annual sales to the salesperson. So we've already done that. Get annual sales. Calculating the average. It's best to always check if your array size is 0 before doing the calculation, because you don't want to divide by 0. So if the length of the array is greater than 0, then you've got at least 1 salesperson in the array. Then you can say average sales equals something divided by the number of items in the array, which is your salespeople.length. Or you could use your constant as well. You could use max size if you want to. Divide by max size. What are we dividing by? And that's, of course, total sales. So we're giving everyone a bonus. We're totaling up the sales for all salespeople, and we're calculating the average sales. Let's display those to the screen. And let's get our formatting flag. We've got it all nicely formatted here. Let's get our string.format. Sales. Same for average. Line them all up so they're neat. And it's average sales we're formatting. And that should be pretty close. Control 1, Control 2. So the total sales, so these are all after adding the $100 on. And the total sales is 266K and the average is 26K. So while we're thinking about adding things into the question, which is a great way to learn, let's also list all salespeople. This is going to sound harsh, but this is something companies do all the time. So list all underperforming people. Okay, and so what does underperforming mean? It means their sales is less than the average. So see if you can do that. That's another thing for you to try and do. Sounds pretty harsh, but that's what happens in real life. If you're underperforming, you might get some extra training, you might get a kick in the pants, or you might get, see you later. Thanks for coming. So list all underperforming salespeople. Let's put a couple of blank lines in. Just now print line. So before and after the totals, we'll do some blank lines. We've got a loop here to display the salespeople. That's going to display all salespeople. We want to do an if statement. If something is less than something, then display them. It's going to be something for the salesperson. something is less than something, we want to display them. So if it's a salesperson's sales is less than the average, we want to display them. Okay, we know what the average is. We've got it right there. Average sales. We know what the salesperson's annual sales are. I get annual sales. Okay, so salesperson is just a salesperson object, and we perfect. Yeah, so Wayne's got it right there. Get annual sales. Yeah, so salesperson is just a salesperson, so we can call any of the methods for that object. So like we can with the array. If we did it for the array, salespeople. That's just a salesperson object, and so is SP. Whatever this guy here is, that's just a salesperson. So we can call any of the methods as well for that person. So this will be all the underperformers. And that's these chaps here. We could even put a bit of a heading on there just to make it even more serious. Is that underperformance? It's changed because we're generating random data. Okay, so these are people a company might want to look at and say, can we give them a new area? Can we give them some training? Can we give them some mentoring them? Or else if we've given them new areas, we give them mentoring, we give them training, we've done everything we could possibly do, they're still not getting it. Maybe they're not made to be salespeople. We might say, well, thanks for coming. Don't come Monday. Sad, but it's what happens. And so that's it for that question. We've done a lot more than we're supposed to do, like you should do for every question. I just said to set each number and display them. We've done a lot more than that. We've worked out, we've allocated random data. We've done a sales increase. We've worked out the total. We've worked out the average. So we've done a lot more than answer the question. We've also done an underachievers report. Let's also do an overachievers or overperformers, our top performers. List top performing. That's where their sales is greater than the average. So again, we might want to put a blank line in there. And just change that to a greater than. Or you might say where it's greater than the average times 1.5. So you might have the top. This might give you good performers, sales are greater than average, but the sales greater than the average times 1.5 might be the real top ones. Okay, so times 1.5. So these are your star salespeople, the ones that do really well. And there's our top performers. So if you had some underperformers and they needed a mentor, the people you should choose should be your top performers. Okay, so.
You could do something similar and find out the really bad ones.
You could, yeah, you could do, yeah, you could say if it's less than average sales times 0.5. So half the average sales, they're the really bad, they're the really, yeah, so times 0.5. So they're the real underperformers, ones that are getting less than half the average. We still got a couple there. These chaps here need to pick their socks up, find a new area, or maybe they just had a bad month. Everyone has a bad month or bad year, and maybe next year they'll do better. Okay, so that was that question. We've really explored that question thoroughly. So one thing you could do for homework if you want to do is change all these loops to be counter-controlled loops and change that loop there to be a enhanced for loop and so on. You can change all the loops around so they're swapped. But we've pretty well answered that question pretty well. And of course, another thing you can do is add their name in here and add name in here and name in there and get name and set name and all sorts of things you can do. We've still got 20 minutes or 18 minutes. We'll have a quick look at, just close some of these windows. Sorry about the flashing. So another one was the 12 ints. Write application that stores 12 integers in an array, display the integers from first to last, and then display the last to first. So display them in forward order, and then loop through in reverse, display them in reverse order. So that's another thing you can do with counter control loops. So the benefits of counter control loops: less code. Limitations: you cannot go in reverse order. You can only go forwards through the array. You can't go backwards through the array. You cannot go. Okay, so 12 integers, you're going to array 12 integers, display them from first to last, and then display them from last to first in reverse order. That's pretty easy. I think you can all do that. What's the other one? Array method demo. Array method demo. Create an application containing an array that stores 10 integers. The application can call 5 methods in turn. Display all integers, display all the integers in reverse order. Display the sum of the integers, display all values less than the limiting argument. Display all values that are higher than the calculated average. Okay, so just add 5 methods here. Display all, display reverse, display the sum, display the value less than the limiting argument. Okay, so you might pass through the value 5 and it'll display all values that have got a value less than 5. And display all values that are higher than the calculated average. So you want to calculate the average and loop through your array. So again, that's not hard. Compared to what we've just done with salespeople, that's a really easy question. Are there any questions on anything we've done this class? Any questions anywhere? Anyone got any problems? Anything not clear on a salesperson demo or the salesperson? Anything, any questions? So the recommended questions for those 3, but there's some other good ones there as well. 1, 4, and 10. That was question 1. Car choice is another good one. That's a nice little, where you're creating a class and then a runner. And that's the array demo method number 4. That's a salesperson one we just talked about. College courses and students, that's another good one. So there's lots of practice questions that you can work on. But so get in that habit of class. So you've got your constructors, accessors, mutators, toString. Okay, so that's just methods you always include with all your classes. And then become comfortable with using an array. Moving through it and calculating, calling methods, and calling the accessors, calling the mutators, calling toString.
So I've got a, I don't know, fairly general question, I suppose.
Yeah, sure.
So very often there's like a calculated value that's going to be displayed. And you've got the option to either calculate that value and store it in a variable and then display it, or just calculate it when it's displayed. Is there sort of guidance on what's best practice, or what's, you know what I mean?
Yeah, sure. So so when you got a derived value or a calculated value, derived calculated value, memory's cheap and And disk space is really cheap. So it's not a bad idea to store it in the class or whatever. But if it's changing a lot, is it changing a lot? So are you affecting the data that goes into that calculation? In which case you might want to just derive it when you need it. But if you're loading an array of salespeople from file and you want to get their total sales and average sales, and you're not going to go through and change the sales later on, then you probably want to make it so that it's stored as inside the class as a total and an average. But if you're going to go through and allocate bonuses and change their sales, give them a bit of a bonus increase and do some corrections and all that sort of stuff, and the total could be changing and the average could be changing, then maybe just derive it when you need it. So it depends on what you're doing with data, how often it's changing. And for assignment 2, it depends on the spec. I'm pretty sure it says in assignment 2, don't store the derived values. I'm pretty sure that's what it said, or that might have been last term. But, so just read the spec as well.
Yeah, I'm pretty sure it does say that.
Yeah. Okay, so. Unless it changes a lot. Otherwise, derive when it's needed. And also, how often is it going to be needed? So how often does it change, and how often do you need it? So if deriving it's pretty expensive, you've got to live through 1 million salespeople, and you need that derived value often, every second or so, then maybe you want to store it. So it depends on how often it's changing, how often it's needed, how expensive is it to derive it or calculate it. Yeah, it's all trade-offs there. So
basically make an assessment on each case of whether it's worth storing it or not.
That's right, make an assessment, yeah. And if it's expensive to derive and never changes, then the answer is easy. Then store it. If it's not expensive to derive, it's really simple to derive, and it changes a lot, then don't store it. So they're the two ends of the spectrum. Then you've got to decide what to do in the middle.
Yeah, I think that's helpful.
Still got 7 people, but people are leaving now. So I think we're pretty well finished for this week. Get lots of practice coding. Go through what we've done. Go through the 2 examples I did in a lecture class. Sorry again, but there was the employee class, which is just a basic employee class, nothing we haven't seen before, and then a pass by reference, pass by value method where I pass an int and see if I can change it in the method, pass an array, pass an employee, and pass a date and so on. Okay, so. Okay, I'll prepare the video straight away. I've got about 2 hours of editing to do on it, maybe 1 hour, 2 hours of editing, and then upload it. So it should be available. So 2 o'clock, 3 o'clock, 4. So around about 4 o'clock, 4:30, somewhere in there, hopefully. Okay. Thanks for coming, everyone. Appreciate your time. Appreciate you taking part. Thanks, Wayne and Jared, for joining in, especially Wayne and Jared. And take care and do lots of that. Okay. Thanks for watching.
Thanks, Mike.
Thanks, Wayne.